and welcome to the Expert Angle program. I am Alex from the Affine Analytics office. One of the great things about working at Affine Analytics is that we have a lot of people who specialize in a plethora of domains. On our show today, we have Karthik Devaraj, who is a veteran AI practitioner and a great data scientist. Welcome to the show, Karthik. When I started in this line of work, there was just business analytics. Right now, it's split into multiple lines of specialization. We have data scientists, we have data engineers, we have decision sciences, there is business analyst, which is again a specialized role right now. So, from your experience as a data scientist, I just wanted to know what exactly is data science?
Data science is the science of decision making using data. So there are two aspects to decision making. One is you're manually making a decision using data, and the other aspect is the decision is being made in an automated fashion. So earlier, what was happening is that the decision making process was very manual. So there used to be a lot of analysts and data scientists who study the data, who analyze the data, and then they make the decisions based on that. Now the problem with that is it's not really scalable. For example, if you're running a campaign, maybe you have 1 million customers with you. So you have to run a campaign on all the 1 million customers. So how do you scale up that decision making process for 1 million customers? So that's where you have to automate the process of decision making.
So when you talk about automating the decision making, are you talking about something like the artificial intelligence, where machines can make the decisions, or?
Yes. So AI is a very broad topic. You can think of it as a very generalized definition of decision making. For example, like if I have to give you a simple example, if you take a traffic signal, now the traffic signal has to make a decision based on the amount of traffic that there is in a junction. So at 7 a.m., the duration of the red signal is probably 10 seconds. But the same red signal at the same junction at 2 p.m. would probably be a minute. So there is a decision being made by the machine itself, that how much time should I show the red signal for, based on the amount of traffic. Now this is an example of the automated decision making, and it's a very simple example of, or rather a very loose example of what AI is.
So AI and ML are almost used synonymously these days. Are they the same field of study?
Well, machine learning is a subset of AI. So the difference between machine learning and heuristic approaches is that a machine learning algorithm uses an optimizer, and the job of the optimizer is to reduce a loss function. And you can say loosely that a loss function is essentially the number of times a wrong decision is made.
So can you give us an example of how a machine learning system would look like?
So think about this, like if you're running a marketing campaign and you have 1 million customers, so you need to make a decision as to which of these customers are going to respond to your marketing campaign. So a simple example for a machine learning algorithm is to make that decision. You give it data, you ask the machine learning algorithm to do a simple pattern matching based on historical behavior of these customers. So it learns from how these customers behaved in the past, and it tries to match these patterns with the new data that it has not seen. And this is the decision making process that goes behind a machine learning algorithm, and it decides based on the pattern it has seen in the past, and it tries to generalize that pattern onto the new data set that you give it. So in the end, it is able to decide whether a given customer is going to respond to a campaign or not.
So Karthik, here is the question that I have been wanting to ask you the entire time. Whenever people mention that they are AI practitioners, they have something or the other to do with neural network based solutions, deep learning solutions. So where does deep learning fit into the AI framework?
So deep learning is a subset of AI again, and it's also a subset of machine learning. Why? Because it's very similar to how a machine learning algorithm works. In terms of optimization and in terms of minimizing a loss function. So why is it synonymous with AI? Is because it tries to simulate how a human brain works. The architecture of a deep learning algorithm is very similar to the, the structure of a human brain. A human brain has a neuron as a computational unit, and similarly, a deep learning algorithm also has a neuron as a computational unit. So these units form a network, and you can train a network to perform a specific kind of task. So why has deep learning algorithms gained a lot of popularity in the recent years is because of two reasons. One is you have access to huge amounts of data, and two is you have access to cheap computation power. And computation power is a major factor when it comes to training a deep learning algorithm.
CPUs won't be enough.
No, you need powerful GPUs, and these GPUs are very they're made to perform a specific kind of task, and that is to perform matrix multiplications, because you perform a lot of matrix multiplications within during the training process of a deep neural network.
So Karthik, can you give us a couple of examples of how you have used deep learning in Affine to solve data science problems?
So one problem I worked on was for an insurance client in the US, where they had to insure a particular property, and to insure a property they have to first assess the risk of the property. And to assess the risk of the property, they have to understand what is there in the surroundings. So for example, if there is a forest, then there's a risk of forest fires. If there's a river which goes next to the property, then there's a risk of flooding. So what they currently do is they send agents who go and inspect these properties, and they inspect, they assess the risk based on the surroundings, and they give it a risk score. Now the problem there is that this process is very expensive in terms of time and cost. The solution here is that we are using computer vision techniques, using satellite images. We would look at a satellite image and perform image segmentation on that image, and pick up areas such as forested areas, or rivers, or parking lots, roads, etc. And after we do the image segmentation, based on the proximity from the building, we can actually calculate risk metrics. So this is completely automated. It cuts down on the cost and the time as well, and this is easily scalable.
Yep, true.
Yeah.
Karthik, it was great talking to you about data science, AI, machine learning, and deep learning. So we figured out that it was kind of like the Russian nesting doll. We open one, the next one is right within it. It was great talking to you about that and how things need to move from the manual analysis and action part to an automated analysis and action. Thank you for coming on the Expert Angle program. Wish you lots of good luck on your next projects. And thank you, viewers, for watching the show. We'll have more interesting topics and more interesting conversations coming for you on the Expert Angle program in the upcoming videos. Stay tuned.